So when we are wiring things up, you'll kind of notice that, these pieces of equipment here, they are not actually mounted down into the boxes. That's because typically when we wire it, we want to see where those wires are connected, make sure that everything is connected correctly. Because if we connect them incorrectly, then we can have like a short circuit, or we can, cause sparks, we can cause a fire, we can shock or electrocute yourself, and that's not what we want to do. Um, a lot of times when I have students wire these things up, you wire it up, it's not plugged into anything, and then I'm the one that actually plugs that stuff in. So that way, um, you can, that way I take that risk of hurting myself. So we've got to be really careful when we're plugging things in. But like I said, I'm trying to work on how I can do something like that with you and make it safe for you to actually wire some stuff up and do some things. It's really basic. If you follow some of these rules and if you follow the diagrams, then we'll be good. On the diagrams, when we do them, I want you to make sure you have the correct diagram. So I'm going to be kind of working with you a little bit, kind of back and forth, and probably next week. I might kind of give you guys a little bit more time. Depends on what we've got here, but I can hang around here and we can, kind of work with you a little bit if you have questions. But we'll kind of work with that. But the idea is not for you to diagram it incorrectly. The idea is that I want you to diagram it correctly. So if you make a mistake, we're going to redo it until we actually get it correct. So it's not more of a test. It's more of a getting you to understand stuff with it. A lot of what we kind of gauge on and with this unit, when we actually wire them up, it's really kind of the same thing. When we wire these things up, I grade these things, on does it work like it should. So if we have a light switch that's supposed to turn on a light, I will give you the points if it does that. And where I deduct points is if we're not following the code. And there's a NEC code, which is the National Electric Code, which sets some basic standards of what needs to happen when you're wiring things up. Sometimes you can wire it up and it'll work, but some things are going to be incorrect. It's not going to be it could be a safety hazard. It's not going to cause like a short circuit or spark, because that means things aren't going to work. But it could be something that, isn't there. So this little PowerPoint is going to kind of go for those types of things. It's going to show you some of those standards and stuff. Codes are going to be different from, state to county to city. Those things are going to kind of, be a little bit more strict. This is just a basic code for their nation. But you can always make it stricter. You can't actually make it less. Some of the equipment that we're going to use, and you'll see these things kind of pop up. We've got this 14 2G wire. This is just we call a Romex wire, and it comes. Can you guys see my screen as well? Can you see my little video?
Yeah.
Okay, so if you can see, I'm kind of holding up right here. This is Romex. This is stuff that you're going to find in your house. Typically, you're typically going to see this stuff inside of your house. It's a 14-2 wire because there are two colors. If I can push this thing up, then maybe I can get this thing done. There are two colors on the inside. It's not wanting to work. Of course you're not. Okay. Let me poke those things through. Okay. There's a little outer coating here. And on the inside, there are two colored wires. There's a black wire, there is a white wire, and then there is a bare kind of ground wire. We're going to explain what these things are, what those mean, and kind of where we need to connect these things. But 14-2, 14 stands for the gauge wire. So that's how thick that wire is. The bigger the number, the smaller the wire is. Okay. Pretty standard 14 gauge stuff. If you have a 15 amp outlet, most of your stuff in your houses are going to be 15 amp. You're going to see a lot of this stuff. 14 3G, still called Romex, but it's a little bit different. This Romex, instead of with the 14-3, instead of having just the two colors, we're going to actually have three colors. And if I can push these things through, come on, work for me. All right. So what we're going to have is oh my gosh, it's not working. Come on. If you can see these, we have a black wire, a white wire, a red wire. That's kind of different from the 14-2. And then we also have that bare wire right there where there's no coating on top of it. Again, it's got a kind of a coating on the inside. Sometimes we're going to use one versus the other. You'll see those in the diagrams, why we would use one versus the other. But both of these things you're going to find in your home. Okay, that's what we're going to use. It's pretty, they're fairly cheap, you know, to buy these things, to wire it up. You know, where it gets expensive if you're trying to rewire a home is trying to take down walls and trying to feed these wires through. It's really easy to feed it when it's a brand new construction. We have electrical boxes that all connections have to be made in. You can't have connections that are outside of an electrical box. So if you've got this Romex wire, okay, this Romex should, you know, go into that box. And then where you have these terminal ends, you're going to connect these to different things. Those are all going to be made inside of junction boxes. They have different sizes, different shapes, but a junction box, right, it's all going to be pretty much the same. This example that you see right here is going to be for like a light switch, or sorry, a light. You might see square boxes, you might see rectangle boxes. Those are going to be for like your switches, your outlets, and different things like that. Oh man. Single pole, single throw switch. See if I can grab one here. This one, that single pole, single throw switch, this is a very standard switch that you're going to have in all of your houses. It's going to say off and on it. Some of the things we may want to note is that there are 2 brass terminals right here. They're kind of a gold color terminal that may not pick up very well on that may not pick up very well on the camera. You okay? All right. There's a ground terminal on here as well. Okay, so we have 3 terminals. There's 2 brass and there's a ground terminal. This thing is going to say on and off. That's how we identify a single pole, single throw switch. Okay. A 3-way switch. Sorry. All right. A 3-way switch is going to be a little bit different. Notice it's going to be a little bit wider than the single pole, single throw. This one we call a single pole double throw switch, or a 3-way switch. It's going to have 1 brass terminal and 2 brass terminals. It's also going to have a black terminal, and then it's going to have a ground terminal on it. The one thing with these, maybe I should click this thing up. The one thing with these is that there is no on or off on this thing. Okay. Does anybody know if they have any 3-way switches in their house? You have a switch that does not have on or off. I'll guarantee you probably almost every single one of you do. Does anybody have a switch where you have to have 2 switches to control 1 light? So maybe like down in the hallway, typically.
Yep.
Okay. Does anybody in here have a switch like that where one of these switches has to be like up or down for the other switch to work?
No.
No? They both, so no matter what, you flip it and it turns the light on or it turns the light off, correct?
Yeah.
That's how it should be. Sometimes if you have to have one of these things where it has to be down or it has to be up, and then the other one will actually control it, that's wired up incorrectly. And we're going to learn in this unit. We're not going to learn these today. We're going to do those probably next week. So we're not going to be messing with these 3-way switches today. We're really just kind of focused on real basic circuits using these single pole, single throws. We have wire nuts. Grab some wire nuts here. Come on. I know I have one. So these wire nuts are going to come in different colors. The colors really don't mean a whole lot except for kind of this green one. This green one is really, designed for ground wires, or those bare wires. I typically don't use those very often. But then we have like yellows and reds, and these do not coordinate with the colors of the wires. So you can really connect these to either one. It doesn't matter. They have different ones. They have orange ones. They have tan ones. But the difference in these is the size on the inside. So how many wires we can actually connect together. So we use these things if we wanted to connect 2 wires together, and you're probably not going to do it with, let me get this thing. You're probably not going to do it with these 2 colors right here. And you're going to have to strip coatings back. And I'm going to show you how to do that later. But you basically just take these things, you twist them on, and it basically just going to connect 2 different wires. So if I had 2 black wires with like these 2 different ones, I would basically, if I didn't have to put it on one of these terminals here, I would simply just connect them together. And so it's just it's called a little wire nut there. And the color of them just has to do with the opening, the size of the opening on the inside of that. So those are wire nuts. Outlet receptacles, okay? You have these things. There's a difference between some of these outlet receptacles. The one that's in this picture is a 15 amp circuit. And we can tell that because it does not have a little line, kind of like this one does right here. This one's got that little dash. That means that it is for a 20 amp circuit. Typically, if we had something that needed to have more power, and this came from our shop, and so we use more power in our shop than you would like a TV or, you know, a lamp in your bedroom or charging a cell phone. It doesn't really take much. So a lot of your home stuff is going to be 15 amps. But anything where you're going to have maybe a little bit more power, you're going to have a 20 amp circuit. This one actually got burnt up. You can kind of see that on that side there, because somebody wired up our shop and they did not do a good job, and it was actually incorrect. And we plugged something in, we had a short circuit, and it basically just blew this thing out because the breaker was not designed to have this. It was actually like a 40 amp breaker, not a 20 amp breaker. They had pulled, you know, one portion of it out, and if it's not set up correctly and you have power that's coming back, it's not going to trip the breaker. And that's what we had. Luckily, we were able to kind of kick that off and get it to work. But you can see a lot of damage here. If that's inside of your wall, that's going to cause a fire. So we've got the electricians out here. I think they did it last year. We got them out here and we got them to fix it because we realized that it was not wired up correctly. So you have safety hazards sometimes, even at a school, because sometimes people don't really know what they're doing with electrical. And if you don't know what you're doing, you can really screw some things up. We have light sockets, right? These things can vary, but, you know, we just use these basic little, you know, plastic ones. You put a light bulb into it. They've got terminals on the back side. They've got 2 brass terminals. They've got 2 silver terminals. With these outlets, we're going to have 2 brass terminals right here, and you're going to have 2 silver terminals on this other side. And this one's also going to have a ground terminal as well. Okay, so it's got a green screw. That's going to be our ground terminal. Some tools that we use, we can use wire strippers. When we do this, I realize that a lot of you may not have access to these things. So when we actually go to wire up some stuff, we will just kind of strip the wires and do that for you. So that way you don't have to worry about that. We also have cable cutters, which we're going to cut the cables down the length. So that's not going to be an issue for you. And then we also have these cable rippers, which these things we're going to use on the Romex. We can take these things on the Romex. It's got like a little like angle portion right there that we can actually take. We can pinch this stuff down. You guys can see that. It kind of cuts that. I didn't cut it very well. Basically just cuts that sheathing, that coating off. One more time. And it allows us to kind of strip this stuff back. So that way we can have exposed wire on the inside of our junction boxes. Okay, so that's what these little cable rippers do. That stuff is all going to be kind of set up for you, so you're not going to have to worry about that. Other than that, it really just takes screwdrivers to kind of tighten things down, and maybe not some wire strippers. We do use these things, but you know, to bend wires and bend little hooks, which we're going to talk about, you can just use any pair of pliers will allow you to bend these wires. So that's kind of all the equipment that we're going to use. Now, typically what we do, and I didn't show you guys this stuff yet. So not only do we have a Romex wire, okay, and not only do we have different gauges, and I just dropped all my wires, so that's great. We also have individually stranded wires. So these things, the Romex stuff, you're going to see like at your house, right? But the individually stranded wires, you're typically going to use with conduit. So you can kind of see there's conduit that's, you know, right up in here. There's different styles of conduit, but if we're running conduit, and this is typically commercial buildings, schools, stuff like that, you're going to see that conduit. You're going to run this individually stranded wire, and you can get them in really any color. We use green, white. My red and my black just dropped off my table on the other side. But I think you guys know what colors are. They're all the same. This is 14 gauge, just like this is 14 gauge. It's the same thickness. But these ones, we can kind of pick and choose which wires we want. On these ones, we get two options. We either have a black, white, and a bare, or we have a black, white, red, and bare. Okay, so these ones, we don't get to pick our colors. You're stuck with what you have. With the individually stranded, you can do that. So if there's no conduit, we don't use this individually stranded wire. We only use this individually stranded wire when we have conduit. If we have Romex wire, we're going to use these little cable clamps that are going to be attached to the junction boxes, and it's going to secure this Romex down so that way it doesn't get pulled through. So you'll kind of identify that, and I'll show you on the pictures, because on the pictures there's some stuff where there's conduit supposed to be there, and there's some stuff where it's just these Romex or these non-metallic cable clamps to clamp down the Romex wire. You're not really going to have to select that stuff, for your diagrams, but we can see that. Duplex receptacle. Nope. When you see a 20 amp a 20 amp here, notice that little dash, and then we've got a 15 amp. They do say also kind of in here, I don't think these pictures show up, but somewhere kind of in this area, it'll tell you if it's a 15 amp or a 20 amp receptacle. Notice the silver terminals that we have here. Notice this wire that's going to be connected. So when we want to make connections to this equipment, we're essentially just going to be bending hooks inside of this electrical, or around that electrical wire, and that hook goes around that screw, and then we tighten that screw down. That's going to make sure that we have a good secure connection. Hooks need to go clockwise, so that way when it goes clockwise, it's going to kind of pull that hook in and really kind of tighten it. If you go counterclockwise, as you tighten this screw down clockwise, it's going to kind of push that thing out. And a poor connection is going to create more resistance in the system. More resistance is going to create heat. Heat can, melt the wires. It can cause a fire. It can have something like this when you have too much resistance. So good, secure, tight connections are what's going to help make sure that you don't overheat any system. And then using the correct gauge wire for it as well. So if it's a 15 amp circuit, 14 gauge wire. If it's a 20 amp circuit, you want to use 12 gauge wire with that stuff. Everything we do is just going to be 15 amp circuits. The wires, you can kind of see an example of the non-metallic cable clamp and the Romex that's in there. Once that enters that box, whether this is Romex or individually stranded, which would be right here where this conduit's at, you need to have 6 inches of free wire. You'll notice on the conduit right here, notice how we have none of that sheathing that's on the outside. All those wires are now kind of exposed. The sheathing is in between where the boxes go. I like to go about 8 inches. Typically what I do is I'll go from my pinky to my thumb. I'll just kind of put it down on the box and I clip the wire. We don't actually have to take a tape measure to it and measure everything, but we have to have 6 inches. That is part of the NEC code. So that way you have enough room to kind of work with. And you can make sure that you get those good, strong connections, and then you just fold the wires up in this box behind the equipment that you're actually putting into it. So this is going to be kind of important when we're actually diagramming. When you are connecting your black wires, right? Your black wires that you have are going to be hot wires. They are going to connect to brass terminals. You are never going to connect a black wire to a ground terminal right here, this green screw. This is going to be on a box, or it can be on the equipment, and you're never going to connect it to a silver terminal like you can see here. Silver terminals are on our outlets and on our light sockets. Okay, that's where we see the silver terminals. We do not have silver terminals on any switch. There's only brass and ground, and maybe a black if it's a 3-way. Your white wires, okay, are going to connect to your silver terminals. Okay, and I'm kind of lying to you a little bit, because what I really mean is your neutral wires. And your white wire, okay, typically is your neutral wire, but sometimes we don't use that as a neutral. Sometimes we use it as a hot. And we'll explain that in one of the diagrams that I go over with you. We're going to explain why we would use that and what that's going to be like. But typically, if it's a neutral wire, okay, all neutral wires are going to be white. And if it's a neutral wire, it's going to connect to a silver terminal. It's never going to connect to a brass or a green one. Now, the ground wires, either the green ones or the bare wires, are going to connect to green terminals. This is always true. All the green wires are always going to connect to a green screw or a ground screw. And the ground screws are all going to be green. They're very easy to identify. That is never going to change in any of these systems. Okay. So green wires or bare wires are all going to connect to green terminals. Okay. It's never going to connect to anything else. How we wire these things up, that can kind of vary a little bit. To get those hooks around these things, what we need to do is take like these wire strippers, and we've got to strip back some of that coating so we expose that wire. We don't want too much. We don't want too little. We want to have it just about right, which is about 3/4 of an inch. So we strip away about 3/4 of an inch of that little coating there. And then what we do, I'll show you some examples here. Well, I'll explain these things. So if it's too long, your wires can be exposed. When you fold them all up into the box, you can touch other wires that aren't supposed to touch, and that's going to cause a short circuit. If you have wire or this coating that's up underneath your terminal, let's see if I have an example here. So if this coating on this example right here, if that coating went underneath that screw, it's going to give you a bad connection. Bad connections are going to create resistance, and it's going to create heat. So when we do this, we take that, we bend little hooks in these things. And I think I have some examples. What you do with these is you grab the very tip, and maybe I'll try to bend a little hook so that way we can see it. That way you guys have an example. Come on. I'll go a little bit more. So we've got our little hook here. What we're going to do is we're going to grab the very tip of this, and all we're going to do is we're going to take this thing, we're just going to bend this around. And what that does is that gives us a nice little hook that's going to be able to go onto a terminal. We can tighten that terminal down, and it's going to give us a good secure connection. An example of what these things look like, if we bend a hook, you'll notice that, see the bottom of this hook is almost kind of even with the insulation. That's exactly what you want to see. If you go too short, you'll notice this insulation kind of comes up on that rounded part. That screw terminal is going to tighten down, and that rubber on the outside, that coating is an insulator. So it is not going to allow a good connection. And if you go too long, it'll kind of hang out past this. And I've got a picture of what it'll look like when it's too long, when it's connected there. So we'll kind of look for that. Yeah, right here. On this example, this is good. This is what you want to see. Hooks going clockwise. The insulation is not underneath the screw, but unlike this one, this is bad. See how far down it goes? This wire is going to expose. We want as minimal exposure on this wire as possible, okay? Because if this thing touches a white, if this black touches a white or a neutral wire, you're going to have a short circuit, which could cause a fire. On this one, you'll notice that this hook is going backwards. This is counterclockwise. That would be incorrect. If we were wiring these things up and this light switch, you turned it on and it did what it was supposed to, I would grade this and I would deduct a point here for that, and I would deduct a point for this one going backwards. Each of these diagrams is going to be worth 10 points. Again, on the diagrams, I'm not worried about that. I want you to get the right diagram. If you get the right diagram and you do the work, okay, you're going to get 100% on this project. What you're not going to be able to do if you get the wrong diagram, I will work with you to make sure that we get it right. Okay, so I'm not going to deduct you points if you don't get these wrong. You can mess these things up as many times as you want until you get it correct, but the important thing is that you get it correct. So having these too long, okay, going backwards with them, that's going to be a poor connection. It's going to potentially be loose and cause a safety hazard. When we put stuff into wire nut, so sometimes we don't actually connect it to a piece of equipment. When we put these wires into a wire nut, we do the same thing. We strip them back about 3/4 of an inch, and then we tighten the wire nut up. You'll notice on this example on the right, this is incorrect. So you can see that wire is exposed. That would be a point deduction. If both of these ones were exposed, that would be 2 points. Okay, so it's pretty simple stuff to kind of keep in mind as you're wiring. This is the correct example. Notice how I can't see any bare wire in there. Okay, if I had this exposure here and I was touching it and I folded this stuff up into the box, these are liable to touch, and the black and a white or a black and a neutral, hot and neutral, those two should never touch each other. Okay, that's the easiest way for us to get a short circuit in our system. The other thing that we got to do when we're doing these systems is we've got to ground these systems out. So any green screw, any green terminal, we need to connect them together. So you notice we've got a green screw right here. We've got a green wire coming, or a bare wire coming from our Romex right here. We've got a green wire coming from our conduit. All three of those wires are connected together. So when we're doing the groundwork, we need to make sure that all the wires get connected together. We have these things called pigtails, and like on this example right here, this is a bad example. Notice how we connect the 2 ground wires, but we don't connect this little ground box right here. This needs a pigtail, which is a short 6-inch piece that does not leave that box. And it basically helps connect those 2 to a 3rd wire and connect those. If you had a switch like this in there that has a ground wire, you would have to have 2 pigtails, one coming from the box down here and one coming from here. What this ground wire does is, in case that neutral wire doesn't allow the power to be carried back, if you were to touch something that has live power to it and you're standing on the ground, especially if you're barefoot, that electricity could go through you. So this ground wire is a safety device. So that way, if there is an issue in the system, it will carry it through the metal components and through these ground wires instead of you. Okay, so it is there for your safety. Some older homes may have outlets that do not have the little bottom ground plug right there. You may just have the 2 prongs that are on the top. The houses like that are grandfathered in. You can still kind of use those things, but there's a better way of kind of adjusting those. You can wire up new outlets. I was helping out a buddy about a month ago. He was doing that because he had an old house and he had all the 2 prongs in there. And there's some ways that we can kind of rig it up. Ideally, rewiring the whole house, but that can get expensive to do that. But again, with electrical, I know I said it in the PowerPoint, when you do this stuff, if you're ever going to work on anything, and you are going to learn some things, that's going to, you're going to know how to change a light switch out, how to change an outlet out. But if you're ever doing any electrical, do not over exceed your expertise. If you don't know, or if you don't feel 100% confident, don't do it. And if you guys ever have any issues or you have some questions, ask me. If you're doing some stuff at your house, I don't care. It doesn't have to be related to school. Ask me. I like electrical. I love the electrical stuff. I do that. I help out a lot of people. I'm here to help you out. I'm here to give you some advice and do whatever you need. So I don't want you to get hurt with electrical. That's kind of the important thing. With this diagram, you can do this electronically if you want. You might and I don't know, it depends on what program you have, but you can use like the draw features if you're doing in Google SketchUp or Word. I'm pretty sure Apple products, Pages, I'm pretty sure they have the ability to do that. Or you can print this sheet off and you can use color pencils to kind of get these lines drawn. If you really wanted to, you could just use a pencil. You can use a black pen. You can use, a dotted and a squiggly line to represent the different colors: the white, the black, the green, and the red. Those are really the 4 colors that we're going to deal with in this. If you do happen to do this and you want to print this off and you want to have a hard copy of it, wrong thing. The one thing that we like to use is, black for black, green for ground, red for red. And then white typically doesn't show up on paper, so I use a yellow pencil instead of a white one, because the white's not going to show up on white paper, right? But just understand that if you do that, the yellow is going to represent that. On the diagram, I'm going to do the same thing. I'm going to use a yellow mark for my white wire because it's not going to show up on these things here. So I'm going to simply just kind of annotate this, and you guys are going to have this video so you can do this. It's the exact same one. What I'm going to want you to do this week is to work on diagrams 1 through 5. I'm going to do 2 of them with you, so you really only need to work on 3 diagrams. That's really your task, okay? And they are different, but there's some similarities. I'm going to teach you enough of what you need to know that you're going to have to create something new, but you're going to have enough of the information. Feel free to send them to me and do this. If you do it on a piece of paper, you can do it on a scratch piece of paper. If you print off that packet, you can do it on a scratch piece of paper, so that way make sure you don't screw it up and have to print off like 50 copies of it. If you're doing it electronically, it's easy because you can just delete stuff, but you can't erase the color pencil marks. So I would encourage you to do it on scratch paper if you do that, or electronically. We're going to scroll down. Well, first of all, I need to explain the key. If it's a dark colored circle, it is a brass terminal. That's what it's representing. If it is an open circle, it is a silver terminal. So these are going to be, the brass terminals are going to be hot wires. The silver terminals are going to be neutral wires. Okay. Every single time. That doesn't change. If it's got a G in the middle of it, it is a ground terminal, and the color is going to be representing a green terminal. So you're going to have one in the boxes, like you can see. Oh, you guys can't see that. But like in the boxes, we had that green screw at the bottom. On the equipment, some of the equipment has green screws as well. Those are going to be represented by a G. I'm not worried about the dark colored circle with a C. That's a common terminal. That's when we get into these three-way switches, which we're not doing this week. And then we also have an I and an O, that's input and output. That all as well is a different diagram. That's going to be for a four-way switch. So the assignment that you have is all of these things. I think I put it to be due 3 weeks from now. So in between now and these 3 weeks, like I said, next week, we'll kind of work with you a little bit on diagrams, have you guys show me some things. We'll talk about it, kind of work together. I'll show you guys how to do a three-way switch as well. But you guys are gonna have 3 weeks to do this. I'm not wanting you to do all 10 of these diagrams right now. Okay, you're not gonna have enough knowledge to do all 10 of them. 1 through 5 is really what I want you to focus on. So as we get down to this, we got a good full, let me do this. Let's do a full screen so that way you can see it. So on this one, it's number 1, we have an SPST that stands for single pole, single throw switch. That is this switch right here. This switch has 2 brass terminals. So those are going to be hot wires connected to there. And then it's got a ground wire. You'll notice in this diagram, if we go to the right, we have our light socket. That's going to be this thing. We have 2 brass terminals here, 2 silver. There is no ground on these. You will notice that in both of these, though, that there is a G there and there is a G there. What that's going to indicate is the ground wire that's in that box. There is also another ground wire that's on our outlet right here. Okay, so brass terminals, there's the dark colored circles. That's going to be your hot wires. Your green and bare wires are connected to the G's. And then your neutral wires are going to be connected to your whites. Now, in every single one of these diagrams, let me get my annotate tool here. In every single one of these diagrams, you're going to have 3 wires coming from your source. And the source is going to be just a plug that you would plug into an outlet. Okay. And every single time in every single one of these diagrams, this does not change. So you can put this on every single one of them. You're going to have 3 colors. You're going to have a black. You're going to have a white. That's going to be represented by our neutral. And then you're going to have a ground wire as well. This is the bare wire or the colored wired green. We're just going to represent it as a green. Okay, so in every single diagram, you're going to have those 3 colors coming from your source. Now, what we want to have happen is this SPST, this single pole, single throw switch. We want this switch to turn on the light when we flip this switch on. Okay, this is a real basic diagram, nothing too complicated. So essentially for electricity to flow, we have to have a circuit. So we have to come from our source with our hot wire. We've got to go into the switch, out of the switch, to our light, and then we have to have that stuff return. Okay, and the return is our neutral wires or our white wires in this example. So what we're going to do is we're going to take our black wire from our source. We're not going to go all the way over to here. That would be wrong, right? That's not right. We want to come into the switch because we want that switch to control the light. If we came directly into our light would always be on. So what we're going to do here is we're going to come into it. We're going to come into this first box, and then we're going to drop this thing down onto one of these 2 terminals. It does not matter on this one which one we connect. Now, what happens on the inside of this switch is as I flip this switch off, and on, I guess it's like that. Yeah. Off and on. Okay. What it's doing is essentially connecting these 2 terminals and disconnecting them. So it's connecting, disconnecting, connecting, disconnecting. So if I have my power coming in to my first outlet, what I need to do is I need to take another black wire and I need to connect it from this terminal into my light. So we're going to do this. I'm not going clockwise. You don't need to worry about trying to go clockwise with this. I'm not that concerned with it. If we're actually wiring things, just understand that you go clockwise with them. So if we follow our power from our source, we come in, we go to our first terminal, If we turn our switch on, it connects these two together, and then power is going to flow from here into here, and then it's going to go to my light. Now we have to complete this circuit. And so what we're going to do is we're going to take wires, and we're going to come back, and we're really trying to connect this neutral or that white wire. This white wire right here is always going to be neutral. We do not want to take a black wire, because this is a hot wire, and hot wires do not connect to neutral terminals. Okay, so that would be wrong. The other thing that would be wrong is that if this is Romex, notice there's no conduit. This right here would be an example of conduit. You can see how the lines kind of go down, as well as right here. If it was conduit, it'd be individually stranded. If it's not, it's going to be Romex, like we can see right here in my video. And you don't have two black wires. So I can never have two black wires running from one end to the other. In fact, I never want two black wires running from here to here, because then I have no idea which black wire is which. So we only want one color of each wire running in between these things. Okay. We're going to go ahead and undo that. What we're going to do is we're going to grab our neutral wire. We're going to take our neutral wire. We're going to carry this back into this box. There is no neutral terminals on this in this box at all. And so I'm going to make a wire nut, and I represent these by a little square here. That's going to represent these little wire nuts, right? Doesn't matter what color it is. Whatever color I'm drawing in, that's what I do that in. And then what we're going to do is we're going to take this thing back to our source. Now let's start over here. We've got our source. We've got our hot power coming in. We come into this. We turn our switch on. Power flows into our light. If we had a light bulb in, it would go up in the light bulb. It would use some of that electricity, and then it's able to kind of return back. If I flip this switch on, this would work. We are missing a step, and that is not safe. And that is our ground wire. Ground wires are never going to change. What we want to do is we want every one of these green screws to come back to here. Now, sometimes what people do, and this is not correct, they say, okay, I have my source. I'm going to connect this ground wire to there, and I'm going to connect this one, and I'm going to go to there. That is not correct, because notice these two green screws are not connected to this one or that one. Okay. So what we're going to do here is we're going to actually wire nut this, a little square, and we're going to do two pigtails. So it's two 6-inch pieces of wire that connect to those screws. I can then take a fourth wire, and then I can connect it to the ground screw over there. Notice how it kind of creates like a spider web, right? If I go from my source, I can have a path to any one of my green screws. So what that's going to do in reverse is bring that power all back into that one green ground terminal that's coming from our source. Okay. This never changes. It may change slightly in, where we have the pigtails and stuff, but in every single one of these diagrams, all the ground terminals need to go back and lead back to your source. They all need to be connected. So you need to be able to draw a path from every green screw and lead them back to your source. If you don't have that, the grounding system is not set up correctly. Again, it's a safety device. Okay. We have nothing that's supposed to be in these bottom boxes right here. Right? We're not worried about that. So, right, we don't even need to mess with those things. We act like those aren't even here. When we actually wire these up, you have 4 boxes, and it's the same exact setup that you have here. It's just in real life, you have 4 boxes there. And some of these diagrams, instead of swapping boxes and moving them and doing all that kind of stuff, we just elect to not use some of these boxes in some of these diagrams. What questions do you have on this right now? This diagram is done, by the way. And if you want to screenshot this so you can mimic it, you are more than welcome to do that. But this is your diagram number 1. So just copy this thing down exactly like I did. You get 10 points for that. Easy, right? Easy 10 points. Oh, man. No. Okay, I need to stop annotating. That's what I need to do. Oh, now I need to erase my marks. Okay, let me do this. Gosh dang it. Annotate. Let's erase everything. Oh, wait, I don't want to do that. We're going to leave those things there, right? Because every diagram is going to be the same. So let's see if we can get this thing set up. Oh, no. Here. There we go. We don't have to redo those. Okay. So diagram number 2. Does this look the same as the first one? Or similar?
Yes, it does.
Okay. What is different about this diagram from the first diagram?
The circuit is on the opposite. It's on the opposite side.
Yeah, we flipped our light versus our switch, right? But what needs to happen in here? We want our single pole, single throw switch, that's this piece right here, to control this light. So when we turn the switch on or off, we want this light to be on or off. Now, this is going to be incorrect, okay? And I'm going to do it incorrectly on purpose because I want to show you what we don't want to do. What we don't do, like the other diagram, is come from our source right into our light, because if we were to do that and connect our neutral back, all that would do is that would have power coming into our light. It would go up, it would return. This light would never turn off. Now, most of the time, if this is like a light in your bedroom, when you go to sleep, you probably want the light off, okay? And so that's why we have to connect a switch first. So this would be incorrect. You don't go directly into your light. We're gonna bypass this light. I'm gonna go ahead and undo that one. So what we're gonna do is we're gonna come into here, and just like we did on the white wire on the first one, we're not gonna connect to anything here. What we're gonna do is we're gonna do a wire nut, and then we're gonna come from there into our switch. So now, just like before, we're coming from our source, we're going into our switch. Now, what we wanna do is actually take power and come from our switch, just like we did before, and go into our light now. So we could do this with this one, but what do we notice here? If I draw a line right there, how many black wires do I have there? It's not a trick question, by the way.
2.
2. Do we have 2 black wires in this Romex here?
No.
No.
No. So we can't use a black wire. So let's go ahead and undo that. Now, I could use a red wire. That red wire is also a hot wire as well. Okay. But if I were to do that, I would be using this one right here, right? And on this one, I have a red, a white, a black, and a ground. Now on this terminal, on this box, is there any neutral terminals on here? Is there any of these open boxes there?
No.
So that means if I use this Romex with the red wire, because I can't select a Romex that has black, white, and ground, it's always going to have a white in there. And because there's no conduit here, okay, I am stuck with 2 choices. I have the 3-wire with the ground or the 2-wire with the ground. I do not want to have a wire that's sitting in this box doing absolutely nothing. You should never have a wire that's sitting around doing nothing. You never cap it off or do anything like that. You select the right one. By the way, this wire right here is more expensive than this one because there is more wire in it. So also from a standpoint of not spending too much money, we want to do that. So we're not going to use a red wire. Okay, what we're going to do, I'm going to kind of skip this right here. We know that this neutral terminal, we want to get back to my source. That is the same for every single diagram that you are going to do. If you have a neutral terminal, you want that to go back to that source. The one thing I haven't mentioned to you, and I want to make sure I mention it now. Do you see these little lines right here? You see that line right there? See this line right there? Those 2 lines are going to indicate that that terminal and that terminal are connected. If you look at my video right here, you'll notice on the bottom of this light socket, there are 2 screws and there's a metal plate that both of them are connected to. It's the same thing on outlets. There is a metal plate, there's a little bridge right there, and those things are connected to each other. So what that means is if I connect here to there, it's connecting both of these. My neutral terminal, if I connect it from here to there, they're connected. If I had another light in this system, I could simply take another one and I could connect this to another neutral terminal, but I don't need that. There's no neutral terminal here. This is the ending of our little dealio. So what we're going to do, we have a black. We can't use a red because we're not going to need the white. So we're going to use a white wire as a hot wire. Notice this white wire is connected to brass terminals. Okay. This wire is no longer a neutral wire. So that's why we say all neutral, this is a neutral coming from your source every single time. It's a neutral. That neutral wire is always going to connect to a silver terminal. All neutral wires are white. Not all white wires are neutral. And this would be an example that we're going to simplify this diagram. We don't want to use a red because we would have more wires. If this was conduit, I would grab a red wire and I would put a red wire there because you get a pick, and I would just not have a white wire in that system. When you do this, what you need to do is you need to take some black electrical tape or like a permanent marker, and you would need to mark both ends. So we're going to do this right here. We're going to mark this end. What that indicates is if somebody comes back into the system later, that tells them that this is not a neutral wire. I am using this wire as a hot wire. I mark it there. I mark it here. And that tells whoever comes next that that wire is a hot. It's acting like a black wire. Does that make sense?
Yes.
Yeah.
Okay. The one thing with these wires that we need to kind of keep note or just kind of, be aware of, all three of this, and this Romex wire, the individually stranded, the three, wire Romex, all of these wires are 14 gauge. Now, theoretically, electricity does not care what color wire you have connected. The only reason we have colors in these systems is so that way we can identify where the wires are coming from, where they are going to, and we can set a code so that way when somebody comes back through because they have to change a light socket or light switch because it stopped working or the socket broke for your light, you know how to reconnect those things together. Okay, that's the only reason we have colors. I could make all of these wires black and I could wire these things up and the systems would work. But in what I don't see, you could clearly see where these wires are at, but you could imagine if they're bundled up, if they were all the same color, how would you know how to differentiate one black wire from the next on either side? You wouldn't be able to, right? So that is why we have colors. It does not matter theoretically, but for the code, it does, okay? So if we have the wrong wires connected to the wrong stuff, it's not gonna work. Let's follow this path real quick. We have our source, we have our hot wire coming in. We don't connect into our light switch. What we're going to do is we're going to come into our switch. Sorry, we don't connect to our light socket. We go into our switch directly from our source. I don't run a wire straight through here. I have to have a terminal end. Remember, you got to have 6 inches of free wire. And if I ran it straight through, that would not be 6 inches. Okay, so I have to have ends in here. I just connect them with wire nuts if I don't have the equipment. It comes into my switch. If I turn my switch on, it connects these 2 terminals together. Power is going to go into my white wire that's being used as a hot. It's able to flow into my light. Again, this is a hot wire, so it's going to be connected to a brass terminal, okay, not a neutral. It goes into my light, does its thing. It comes back and could come back into here, right? There's a plate that connects these 2. It returns back to my source. Do I have a circuit now? If I flip this switch on, do I have a closed circuit or a circuit that will allow electricity to flow? Yes or no?
Yes, but it's not finished.
But it's not finished. Very good, right? What do we have to do?
Ground wire.
The ground wire. Now, again, the ground wires are not going to be any different. On the first diagram, what did we do? We had 2 pigtails coming off, right? On this one, we only have 1 ground. So what I'm going to do, just like we did before, we're going to wire nut. That's a really horrible square. And we're going to connect to that ground wire. Notice how I cross these wires. That's not them connected. Okay, if I cross them, they're not connected. The wire that is in the Romex is going to also be connected to that. So there's 3 wires. And then on here, I'm going to wire nut. Actually, you know what? Let me do this real quick. What you don't want to do is go to here and then to here. Some people do that. On these terminals that you have on any one of these pieces of equipment, you can only connect 1 wire per screw. We don't layer 2 wires on there. So how I wired up this ground right now, that is not how you would do it. Okay. What you would do is you would do the wire nut, and that allows you to put a wire there, a little pigtail, and also put a wire there. So it splits that power. That's the correct way to do it. You do not put 2 wires on one terminal. It's 1 wire per terminal, but you can split it with the pigtail and that wire nut there. What questions do you have? This diagram is now complete. So now you have 2. That's 20 points that you should have easily. Nothing? Does this make sense?
Yeah.
Cool. We are going to erase this. If hopefully you guys get a screenshot of this, maybe, so you can copy this. If not, the video's up. You guys can watch the video and get it again. We're going to erase all these lines again. I'm just going to show you this next one because we are not going to be doing this one. You're going to be doing this one on your own, but I just kind of want to explain a couple things here. So your goal is to get 1 and 2, just get those ones diagrammed. And then I want you to work on 3, 4, and 5 on your own. Now, when we introduce 3, what we have is a hot duplex. That is going to be this thing. When we talk about a duplex receptacle or a duplex, that is this. When we use the term hot, we mean that this thing is always going to be on. So it doesn't matter if the switch turns on and off, this thing needs to stay on. So you can liken this to, like, your room. I'm assuming most of you have cell phones. I'm assuming that you plug them in at night when you go to sleep. When you go to sleep, you turn your switch off for your light. So you would take this switch. This switch is supposed to turn this light off, so that way you can sleep in the dark. But you plug your cell phone in and you want that to charge while you are sleeping. If this light switch turned off this duplex, then your phone would not charge. Or you would have to leave the switch on so that way your phone would charge, and then this light would also be on as well. Okay. Sometimes some of you may have a house where maybe one duplex, like maybe in like a bedroom, the switch will control that outlet. Does anybody have that at their house?
Yeah, I do.
Okay. But you probably, I'm going to assume that you do not have a ceiling fan or any ceiling lights. Am I correct?
No, yeah, we don't. We don't have anything like that.
Yeah. So those are designed, and typically, older homes are like that. Newer homes, typically they put ceiling lights in and ceiling fans, or at least a ceiling light. But a lot of times what those were designed for was a lamp. You plug in a lamp into that outlet. So it's a very specific outlet that you plug into, and that switch will control that outlet. And so that's probably how you get light, I'm assuming, in your bedrooms and stuff like that, is with a lamp. But that's what those things are designed for. Not all outlets in your room are going to do that. That outlet in that example, that would not be a hot duplex. Okay. So that would be a switched duplex, meaning that the switch is going to turn that duplex on or off. In any one of these diagrams, if you see a duplex, it is always going to be hot. It always needs to be on, no matter what position that switch is in for your light. Okay. We're not trying to make things complicated, but understand that you can do it that way. There's a lot of different things that you can do.